Welcome everyone, daily.dev Dev episode number 36. Usually I can't remember the number, but today I can because this will be the last episode of 2023. I see some people here. Let's make some noise in the chat. Hello guys, hello Dang, how are you? Tell us in the chat where are you from, why are you here? And today we'll talk about PWAs. So first of all, we should understand what this acronym does mean. I think you can spot it in the title, but still. So first of all, sound check. How are you?
I'm fine. How are you?
I feel great. Hey Kenneth, how are you?
I'm great. Yeah, nice seeing you all.
Nice. Okay, we see some people here in the chat. Hi everyone. So a short recap of what we'll do today. So we will have two presentations, maybe three, and we'll have around 30-40 minutes per presentation, and you can make your questions in the chat, and after any presentation you'll have a 5-10 minutes Q&A. So this is how it works. I don't know how many people have already been here. Let me know in the chat. And that's it. So today we'll talk about, of course, progressive web apps. Talking about progressive web apps, this is a good hook. Daily.dev is a progressive web app. So we have been like this, I think not since the beginning, but after a while. And so I also want to know more, and I want to see the progress. We'll talk about the state, the future. It's also good, like, because it's the end of 2023. So we have so many, like I say, good promises and wishes for 2024. So nice. Without further ado, I think that we can start with the speakers. Let's go in order, just to be sure. I'll double check. And so hi Tarun, hi Rahul. We will talk with Danny. So Danny and Kenneth. Danny, Kenneth, I'll kick you out, but promise that I'll get you in soon. Okay. Bye. Danny, thank you so much. Thank you so much for coming. Let's have just 2 minutes warm up. And then, of course, we can have your presentation. So, one moment. So, Danny, can you please introduce yourself and tell us a bit more about the presentation?
Yeah, sure. My name is Danny Moerkerke. I'm a freelance JavaScript and TypeScript developer. And I'm also very passionate about PWAs. I live in Amsterdam in the Netherlands. And what I want to tell you today is about the current state of PWAs, where we're at, all the exciting new features that we've gotten this year, and where we will be maybe heading in the future.
Nice, and super excited. Let me share the screen here. Nice. So best of luck. If you have any questions, just drop them in the chat, because I'll lurk around. And after this, of course, we can collect them all, so we have some Q&A session. Best of luck, Danny, and see you soon in around 55-30 minutes. Okay?
Yeah.
Bye-bye. Bye-bye.
Thank you so much. Thanks, Francesco. Well, welcome everybody. Thank you so much for joining. Like I said, today we're going to talk about the state of PWAs. It's been quite an exciting year. There's a lot of new features that have been released this year, and there's a lot of new stuff also coming. Well, you already heard a little bit about me. I'm Danny Moerkerke. I'm a freelance JavaScript, TypeScript developer. I currently do most of my work at the ING Bank Amsterdam in Netherlands, where I'm working on the design system, the internal design system with web components. I also publish a weekly newsletter called Modern Web Weekly. I really like to test new browser APIs and new stuff, and I write about it almost each week. I try to release each week in this newsletter. You can also find me on X. I tweet quite a lot about the stuff I do. I'm also on Medium, where I write quite some articles. And what brought me here, actually, I'm also the creator of What PWA Can Do Today. And this is a showcase of what is possible with PWAs today. The nice thing about it is that it's also PWA itself, so you can go to the web app and then install it to your device and then you can see for yourself what is supported on your device. Works both on mobile, tablets, and desktop. I regularly update it, so keep definitely check it out. And like I said, this year I luckily got to put a lot of new demos on it because, yeah, PWAs basically they have never been better. They're better than ever. It's been quite a while since PWAs have been around, but this year has really seen a lot of good stuff. PWAs are now supported on all platforms and devices. You can literally install a PWA anywhere. You can use it anywhere. You can install it from almost any browser on any device. Like I said, there's a lot of new and upcoming features that have been released that are upcoming. We'll talk about it in this presentation. And you will also find that most of the new things that have been released this year are on iOS. iOS, of course, has always been the elephant in the room. The support has been lacking. It's still lacking, but luckily the Safari team has been catching up. And there are a lot of new changes coming, so hopefully that will be right up to par with each other in the future. So let's look first at what your web app can do today. What are the features that you can start using today if you want? Some stuff that's been coming out this year that's now universally supported. And yeah, of course, the biggest one this year was the push notifications. Your web app can now send and receive push notifications. It's been supported on Android and desktop for quite a few years now, but this year it was finally released on iOS and iPadOS, of course, also. The cool thing is even when your app is not running, you can send push notifications. So that's really cool. It's really cool for user engagement. Basically, how it works is that your users can sign up for push notifications in your progressive web app. And then even when the app is not running, you can send them these things. So it's kind of cool. On iOS, it still only works for PWAs that are installed. They have been installed to the home screen, so it won't work in the web app right now. It might be coming in the future, but right now you still have to install it to be able to use push notification on your iOS device. Another thing is that the integration with notifications is a bit limited at the moment. On other platforms, you can do a lot more with buttons and event handlers and all that stuff. And on Android, you can even you can configure your own vibration pattern that will be executed when the user when the push notification is delivered. On iOS, this is unfortunately still quite limited, but hopefully that will change in the future as well. Another biggie this year was the file system access. Your web app can now interact with the native file system of your device or the origin private file system. Basically what that means is that now when you have access to the native file system of your device, you can just create files there, you can save them, you can even iterate over directories, so you can create your own file tree component. I actually have a demo of that on what PWA can do today. Mobile devices currently only support the origin private file system, which is like a virtual file system. So you can put files there and your app can interact with it like it was a file system, but it's all virtual. That means that the files that you save there do not necessarily correspond to one-on-one to a file on your native file system. Maybe the native file system access will also come to mobile, but right now it's only, like I said, the origin private file system. It is a very cool thing though. It's highly optimized. It's something that Photoshop is now on the web, as you know, also uses it to temporarily store stuff. It's really highly optimized. So if you need something to save files and retrieve files with very good performance, then the origin private file system is definitely something to look into. Another thing that web apps now all have on all browsers, all devices, is persistent storage. So that means that your web app can now request to save data that won't be periodically evicted by the browser. As you know, some browsers may choose to evict, delete the data that your web app has stored when they see fit, and that might be when you didn't interact, or you're not using the web app anymore, or maybe when your device runs short on storage space. When you have persistent storage, that won't happen anymore, only if your device is really full and it needs to evict some data from there. You will still see some pop-up coming, some dialog coming, so you can choose what to evict. But when you have persistent storage for your web app, you don't need to have to worry anymore that it will just disappear someday and without you knowing it. Now, you may have heard that Safari is quite aggressive with this. They will delete files from web apps if you haven't interacted with it for 7 days. But PWAs are absolutely excluded from this. By the way, this is only the case when ITP, Interactive Tracker Prevention, is on. If you don't have that on, that won't happen. But when it is on, it might happen that a web app that you don't interact with, its data is deleted, but it definitely won't happen for progressive web apps. So that's really cool stuff. Another great thing, biometric authentication is now universally supported, which means that you can let your users log into your web app. They can do it with Face ID, fingerprint, or maybe an external USB key. And that, for the first time, really enables you to get rid of passwords altogether. You know, we all know passwords are quite awkward. They can be stolen. They can be lost. People reuse passwords everywhere, so they become an easy target for hackers. If you put biometric authentication in place, it will be much, much safer. The only thing is you need a backend for that, but the backend will basically only save some metadata, and they will save your public key. So whenever that gets lost or stolen, it doesn't really matter, because the public key is useless without the accompanying private key. So it's really a much safer way of authenticating your users. It's also much more convenient, especially now that there is also an autofill option for the standard HTML text inputs. So you can put autocomplete, I don't know the exact, I think it's autocomplete web author or something. But what that does is, as soon as you focus that text field, the native dialog will pop up, and that will ask you to either put your fingerprint or use Face ID like you normally have already. So really cool. That means you can now use it in your web apps on all browsers. Another thing that's now coming is the contact picker, which is almost universally supported. It is now supported in Safari, but you will still need to explicitly enable it in the feature flags. But that means that your web app can now access all the contacts of the user's device. So what happens if you click a button and you open the contact picker, it will just open the native list of contacts on the user's phone, for example, and then they can pick one. Right now, it's only only one by one, so you can only pick one contact at a time. Hopefully, that will also change a bit in the future, so you can take more contacts. So, for example, you can have a web app import all your contacts at once, which should also be a very nice addition. Now, in addition to these features that are used universally, they can use it anywhere. There are also a couple of browser and OS-specific new features. Now, notably, the best one is the improved install UI, which is now available on Chrome on Edge on desktop, and also Chrome on Android. You probably have already seen the install icon that you can see here in the screenshot in the address bar on the right. That has been there already for a while. So when a web app can be installed as a progressive web app, that will show up in Chrome and Edge. But now when you click it and the web app has the right configuration, you will see a much better UI. As you can see here in the middle, you can put a description there, and you can also put a few screenshots of your app. And what it does, it aligns a lot better with the install experience that users are used to when they install an app, for example, from the Apple Web Store, from the Google Play Store. So this aligns much better and will hopefully help familiarize people better with progressive web apps. Here's a close-up shot. On the left, you see what you just saw in the shot before, which is on desktop. And on the right is the one that shows up on mobile devices. So as you can see, you can put screenshots from the app in a desktop environment and also in a mobile environment, which is pretty cool. And it's also pretty simple to implement. The only thing that you need to do is add this stuff to your manifest.json. In the screenshots key, you can put a source there, sizes, type and form factor. Now the type is currently limited to PNG only. And the form factor that you see there is narrow is for mobile devices, and wide is for desktop devices. So that makes the distinction, like you saw in the previous slide. The form factor wide will only show up on desktop, as you see on the left, and form factor narrow will only show up in mobile devices, as you see on the right. Currently, you can put a maximum of 8 screenshots. So it's up to you how many you want to put for desktop and how many you want to put for mobile. But that's it right now, maximum 8. If you put more, they will simply be excluded by or ignored by the browser. Another big one also on Apple devices this year was the web apps that you can add to the dock in macOS. It's actually a pretty nice implementation. It has some bugs still. It's quite limited, but it behaves quite well. If you have a manifest file for your progressive web app, it will take the icon from there. It will take the title from there, and it basically works quite good. It also shares cookie with the web app. So let's say that you are logged in a web app, and then you add it to the dock. And if you open it, then you will also be logged on there. So that's pretty nice. Like I said, it is quite limited still. You can't do too much with it, but what you can do is quite well implemented. Another thing that is finally now is implemented on macOS is the PWA shortcuts. And that was already, I think it's been 5 years already that it's been available on Android. On Android, if you have a PWA installed and then you press and hold the icon, you will get a similar context menu like this with a few shortcuts. So what you can do is you can add a few URLs in your PWA there, so it allows for quick actions. And this is finally now also on macOS. 2 very strange things though. It's only available when the PWA is open on macOS. So when it's sitting in your dock and it's not open and you right click it, the shortcuts won't show up, which is a bummer actually, because that would be for me the perfect use case to have them. But you have to open it first. And another pretty strange thing right now is that it's for PWAs only. So if you add a web app to the dock through Safari, you won't have any of these shortcuts. But when you install a PWA through Safari, through Chrome or Edge, for example, and you open it, you will have it. So hopefully that will also come in the future, but it's pretty strange that it's only supported for PWAs right now. Adding shortcuts is also quite simple. Actually, you put it in the shortcuts key in the manifest.json file. You can give it a short name, a description, and a link that you go to, and that's basically how it works. I don't think there's any limit to it, not that I know of. But of course, if you put like 25 in them, it won't be that helpful anymore. Anyway, these have been the specific features, universal features. Now let's also look at some of the upcoming features, because there are some quite cool upcoming features as well. And some of them have already been implemented in browsers. Now, the biggest one, of course, this year was the view transitions. Really cool. It enables you to create native app-like page transitions. Currently, it's only for single-page apps. but it allows you to do that with native CSS transitions, and I'm really happy with it. Because to be honest, what PWA can do today is a single page app, but basically the only reason for that is that I wanted to have like cool app transitions. As you can see in this this video, that's the only reason basically that I needed this, because yeah, that's the only way basically implemented with a single page app. And it is quite hard to pull off. What you see here is always 2 pages that are in the DOM simultaneously, which is not great, of course. And it's pretty hard to implement, and it also, yeah, it's quite buggy on iOS. If you go to one of the demos and then you swipe from the left to the right, it reloads. It's very hard to get right on iOS. But I'll show you the video again. What you see here is purely CSS transitions. That's really all, and it's kind of easy to implement as well. With a few lines of CSS that I'll show you later, you can implement this. And yeah, it also combines pretty well with the navigation API, which is another API that's also being implemented in Safari right now. It's already implemented in Chrome and Edge, and that makes it a bit easier to do navigation for a single page app. If you ever build a single page app, you probably know that you need to work with the history API, which has some foot guns and yeah, strange behaviors. The navigation API makes it much simpler to do. Like I said, currently it's only for single page apps, but you can already do it in multi-page apps. If you go to Chrome Canary with the advanced web features on, then you can see it there as well. So that means that if you have like 2 completely separate HTML files, maybe an index file and a detail page, you can have a very similar, like what you saw here in the video, similar view transition like this across documents. Let me go to the next slide. Where were we? Oh yeah, just to give you an overview of what you can do, because my view transitions for what PWA can do today were of course quite simple. But this is from the article that Jake Archibald, formerly from Chrome, wrote on it. Jake Archibald has really been the driving force behind these view transitions, and this gives you an idea of what you can basically do with it. This is of course also not earth-shattering, but I hope it gives you a nice idea of what you can do with it. Oh, there we go. Another very cool thing is that the transitions that you do with the view transitions don't necessarily have to be page transitions. Basically, what the view transition API is, it allows you to transition between DOM states, so that never has to be 2 separate pages. It can also be like, for example, what you see here. Very cool demo from Adam Argyle. What he does is he adds and removes rows from a table, and he uses view transitions for that. So not at all a page transition, but just between two DOM states, which is actually pretty cool. Oh, sorry, wrong slide. Yeah, so I said this is actually pretty cool. How it works, basically, to give you a rough understanding, is you call document view transition, and you give this a callback that actually does the transitioning of the DOM. So that can be, yeah, it can be quite a simple change, like maybe removing a row from a table, like you saw in the Adam Argyle demo. The cool thing about it is that it completely enables you to detach the transitioning from the DOM update, which is also something that's really nice about the view transitions. I could probably talk 2 hours about view transitions. It should be its own yeah, presentation. But just to give you an idea of how this works, I already showed you the document start view transition function. This is called, and you give it a callback that actually does the updating of the DOM. What it does is it creates a screenshot of the old and the new document states. Now, the old view is just a screenshot, and the new state is a live presentation of the new view. And I think it's brilliant. Both of them are rendered as pseudo elements. And this is also what enables you to make it really simple to provide a view transition for this. Actually, if you call document view transition right now and you transition from one state to another, it will already give you like a crossfade, because the standard animation that is defined for these is that the old view will animate from opacity 1 to opacity 0, and the new view will animate from opacity 0 to opacity 1. So even if you don't define any CSS for that view transition, you will already get a nice crossfade for that. Now, if you do want to create your own animation for these view transitions, just to give you a rough understanding of how it works, in the top here you see the shared styles. Now you see two pseudo elements there, which is the view transition new and the view transition old. And what you see there is the root keyword. Now, the root keyword basically transitions to or translates to the HTML root. So if you want to translate or transition the whole page, you can simply use that. You can also use any other element. So let's say that you only want to transition an image or something. You can give it a view transition name CSS property and just give it another name, and then you can use it there. And the cool thing about it is that you can just you can animate any div or any HTML element on your page separately. You can do whatever you want with it, and it's actually quite simple. So what you see here on the top is, I used animation for this. The top is the shared style, so the duration, timing function, and the direction. What you see here is the old view. So this is what I use in what PWA can do today. I left out the keyframes, but I think you get the idea. You see the old view has view transition old, and it has an animation name of slide out. So the old view slides out for a bit. And then the new view, like I saw here, is slides in from the right, and that has view transition new. So this just gives you a rough idea of how simple it is. If you want to know more about it, Google View Transitions. Jake Archibald wrote some really cool articles about it. I also wrote about it on my blog and Medium. But yeah, it's a brilliant concept. It just shows you the old and the new state as pseudo elements, which are very easy to animate with native CSS transitions. So that really helps you to get rid of clunky DOM manipulation that you have to do. And if the future brings this also for multi-page apps, you don't even need a single page app anymore to get some really app-like transitions in your app. Now, another cool thing that I recently added a demo for to what PWA can do today, and this is basically one of my favorite things, is background fetch. And this enables your web app to download files in the background, and it can do so even when it's not running. So a use case for this would be like a podcast app, or maybe even something like Netflix. You want to download a very large audio or video file in the background. Now, if you do that today with a web app without background fetch and you close it, and then you come back, you have to start all over again. In this case, this is not the case. What you can do with the background fetch is that you can download the app in the background, and when you close the web app, it will continue to download the app in the background. You will see a nice progress indicator in your notification center on Android, and then when you come back, it will just pick up where it left off, and then it will continue to download, or when the download has completed in the background, when you were not interacting with it, it's done. So for example, you have a podcast app, you start downloading a new episode, you close the app, and then when you come back, it's probably downloaded already. let me show you this on a screencast I did. So here we go to the background fetch API demo. I'm downloading three, well, basically fake files here. You can see the first one is starting. Now you close the app, and then when you go to the notification center here on Android, you see that the app is still running. Now I put the flight mode on, so the network is gone. You can see it's pausing, and then when I enable it again, after a few seconds, it will pick up and start downloading all the files again. Here comes the second file, and then when we go back to the app, and then we go back to the demo, you will see that it will hopefully pick up again. Now 46%. And then after a few seconds, it should pick up where it left off. So that's it. Really cool technology. Coming very soon. It's already been supported in Chrome and Edge for a while. It's now already supported also in Safari Tech Preview, sorry for that. Actually, it's being added right now, so all the interfaces, all the objects are already there, but it's not really supported or not fully functional yet. But since it's there, it will probably come in the foreseeable future also in Safari. So that means all main browsers will have this. Now, let's look at what you can do today also, how you can make your web app a really great PWA. What you can do already today with any web app is that you can work offline, and this is something that I also hammer on every presentation I do. Make your web app work offline. Please do it. This is something that can be really useful. And I always get the question, like people saying, like, yeah, but I have this messaging app. I need people to be offline or online all the time. Otherwise, they cannot send messages to each other. That's really not the point. The point of offline is this. It means that your users are increasingly on mobile devices. And these mobile devices can be on flaky, intermittent, and very slow connections. If you add a service worker to your web app, it means that all the static assets can already be cached. So all your images, all your scripts, all your CSS file, all stuff like that can be cached. You can go even further than that, but this is basically the baseline of what you should do. And it means that even if you have a app that needs to be fully functional, always online, like a messaging app, when your user is using this in a bad network condition, the assets will already be there, so it doesn't have to download it anymore. So that will really give you an edge to that. So please always do this. Always put a service worker in your web app. You also need to send push notifications, like I said before. Great for user engagement. You can also use it when your web app is not running. You can access the native file system. You can use biometric authentication, like I said, Face ID, fingerprint, and the external USB keys as well. And then you can also use persistent storage and even download files in the background. So these are just 6 features that can use today, and that can greatly, absolutely greatly improve the user experience for your web app. So looking forward, will 2024 be the year of the PWAs? Well, I certainly hope so. I think if 2003 was a prediction, yeah, I think we have good times ahead of us. We got push notifications. You can now add web apps to the dock in Mac OS. We have shortcuts. The install UI on Chrome and Edge has really improved. We have file system access, and we have persistent storage. And then, like I showed you, really cool technology, view transitions, background fetch, and the contact picker. Of course, they're still work in progress on Safari. But yeah, it's already there. It's coming. Even Safari is slowly implementing. So I think this is, yeah, absolutely. It's been a fantastic year for 2020. 2023 has been a great year for PWAs. So let's hope that this trend goes on. What we may get in 2024, these are some rumors and some stuff that has already been confirmed. But of course, very big thing, side loading on iOS. This means that you can, or you may be able to download apps outside of the App Store, the Apple App Store, like you can already do on macOS, of course. And that would mean that we can finally get like real non-WebKit browsers on iOS, so like a real Chrome browser on iOS. You probably already know we have Chrome, of course, we have Firefox on iOS, but under the hood, these are really WebKit browsers. They have to use the Safari technology. So any feature that is implemented on Chrome but is not implemented in WebKit won't work on iOS. Hopefully, if we can now install a real Chrome and it will have access to all the hardware features, PWAs will make a giant leap. So let's hopefully that will come as well. Of course, better PWA support. There's a lot of more stuff scheduled also for Chrome and Edge, other browser, and let's hope so with the with all these new features that have been coming in the past year. This will also mean better adoption of PWAs. I talked to quite some developers, and I can really see that the enthusiasm for PWAs is really increasing. People are really giving it a spin. Of course, there are a lot of people who are also still skeptical about it, but while the features are coming out, let's hope this will also lead to better adoption of PWAs. I try to do my part with this, with regularly updating what PWA can do today. Every time there's new stuff, I try to put a new demo there as soon as possible. So definitely check it out. Also my website and my articles on Medium. I try to spread the word, and hopefully I help with a good adoption, better adoption, and a very bright future of PWAs in the future. So on that note, thank you for joining.
Thank you so much, Danny. That was a really great presentation. We have
my pleasure.
Thank you so much. So we have some questions ready. Would like to start with a couple of technical questions. So the first one is sometimes people ask, sometimes they don't, but I'm sure that someone would like to have this. Is if this presentation is available somewhere, or you want to share some specific links, because you mentioned some links about the presentation.
Yeah,
we find
I did.
An article. You can put this.
Yeah, I will share the presentation, and while Kenneth is talking, I will put some more links there.
That's so a great hook to keep people in the event. So thank you. That's amazing. Nice. Okay, absolutely. So we will share more links soon if you want. Nice. Of course, we have some compliments, of course, absolutely well deserved. We have some time, so we have some time today. If you want, you can drop even more questions. Let's see. I would like to start. This is not really a question, but maybe we can discuss a couple of minutes on this about the pre-read list by John Zayes. Do you have any comment on this? Not really a question.
What exactly does that mean?
Can you read this on the screen?
Yeah. Pre-read list. What exactly does he mean?
I don't know. Maybe it's sort of fetching. I don't know. John, if you want to drop exactly what do you mean? Maybe a prefetching list. I'm not sure 100%. Why has Apple taken this long to implement side loading?
Well, there's a lot of speculation about this, but I think it's just their, of course, their financial investment in the App Store. Of course, Apple is making tons of money with this. Their stance has always been security, privacy stuff. I do believe that. I do honestly believe that also that has been some of the reasons why they do not allow side loading. But then on the other hand, there is also side loading on macOS. You can install any app you want. which is not the case on iOS. So I think the main reason for that has been the financial investments in the Apple App Store.
Yes, I agree. Let's go. Let's go. We have a couple of more questions. You have time to drop them now. Thank you so much, of course, Danny. How well is PWA supported in Firefox?
Firefox is quite good. It's a bit above Safari right now. I have to admit I haven't checked the last couple of weeks anything in Firefox, but I know that you can now also install on Firefox Android. You can also install PWAs, and they work quite good. So definitely check. Can I use? You can also install what PWA can do today through Firefox on an Android device, so you can see for yourself. But it's not as good as the Chromium-based browsers like Chrome and Edge, but definitely better than Safari.
Nice, thank you. I have one by me. It was also out of curiosity, also because as I say, that daily.dev daily.dev is a PWA. What's the feature that you are more excited the most about? So maybe that can be useful, maybe to check it out, even for us, for our engineers, for our team. Because you mentioned many, before, but
yeah, you mean like the feature that we have now, or that's upcoming?
Yeah. What's upcoming, or maybe it's about to get released, like something that caught your attention.
Yeah, what really caught my attention, of course, like I said already, is the view transitions. That really allows you to make really cool animations. Of course, animations is not only about coolness. It can also how do you say that, communicate relating stuff in web apps. It can guide a user through a user flow. So I'm really happy with that. Another thing that I'm also excited about is just a proposal from Microsoft that is about a more universal install experience. Of course, as you know, the install experience is quite different in different browsers. Chrome and Edge on Android have a really good install experience, like I already showed, but on iOS we really don't have that. It's still, you have to go to the share menu, and then you have to go to the add to home screen. So hopefully, if we get Apple on board, we will also get like a more universal, like you have with native apps, basically a more universal experience to install apps. It's not maybe a very sexy feature, but it's really something that we need for progressive web apps. And another thing, I'm currently also building a fully WebRTC communication app. It's a bit like WhatsApp, but it's fully based on WebRTC. That's also another thing. If you want to call somebody from a PWA right now, you cannot do that. If you install the WhatsApp native app, it's no problem. You can just have a full screen. Somebody is calling you, whoever. We don't have that yet with PWAs. I have no idea if that is upcoming, but that would really be nice. If you have a PWA, you can call somebody like you can do with WhatsApp. That you can, when somebody is calling you, have like the whole screen, like a full screen notification. Let's put it that way. That would be really nice.
Nice. Thank you so much. We have a couple of more, and then I think that I'll let you go. Thank you so much, Danny. It was really great insights. Rahul is asking, do you think it is ideal to persist bigger files? For example, core feature was not that.
Well, I think it already bit depends on also what you can do. I haven't really tried it yet, but that's a very interesting use case. I think I got asked that before on X as well. You could try to maybe put it on the origin private file system. Like I said, that's really optimized for fast read and write. I don't really have any experience with WASM, but you could give it a try. I would say it's still also a part that's really being developed right now. So it might change in the future. So I would say just try it out, and please let us know how it works.
Just hack it.
Yeah, absolutely. I think that's also what I do quite a lot. I find out stuff. Max Furtman is also a person who does even more hacking with PWA. He writes about it regularly. It's how you find out stuff, and it's also fun. Let's put it that way.
Nice. Thank you, Danny. I don't know if you deserve this, but I have one last hard question for you, and then we are done. Okay, so this is the last interview question, like the hardest one. So, what reason may make you choose the native development over PWA, considering PWAs provide access to most native features?
Yeah, well, of course. No, I think that's a really good question. Of course, the support is still limited. What really caught my attention is, of course, that it enables you to build an app with just one technology. You can just use web technology, HTML, CSS, JavaScript for that. And it allows you to roll out an app on 3 platforms. There are other stuff, notably Flutter, you can do that with as well. But yeah, PWA just makes it really much easier. It also makes it much lighter. This usually is much lighter than any native app to do. And of course, you can have basically automatic updates. It's not like you have to go to the App Store or something to get a new update. You can all do it automatically if you have a new version of your PWA. Basically, what you have to do is deploy a new server or new version on your web server, and you're done actually. And the findability is also great. You could also say, of course, the curation and all that in the App Store could also be a plus, but I think it's also a big plus that web apps are basically out there on the web. If you want to share a web app, you just send a link to somebody, and then you can share it and install it. So those are the 4 things that basically make me choose PWAs.
Nice. Thank you so much, Danny. So
thank you so much.
I think that we are done with the first presentation. If you have time, Danny, I'll invite you again after Kenneth's presentation.
Please.
Yeah. That already made my year, let's say. So it's we are almost at the end. So thank you.
Thank you for having me.
Bye. Okay, we are at the end of 2023. So of course, our guest at the end should be top notch, the best. So Kenneth, welcome, and please introduce yourself. I think also the title of your presentation fits in this last talk of 2023, because I let you tell the title. I have it here, but I want to let you have the honor. So please, Kenneth, introduce yourself, and then once you're ready, you show your screen, and then we can start this one. Thank you.
Yeah, I think you should actually just get started, because I'm going to introduce myself as part of the presentation. so okay. Let's me, if you can hear me, it's all fine. You see my slides?
I think yes. So as usual, you have around 30 minutes. Take your time, even 35, whatever you want. At the end of this presentation, we'll have a Q&A session. Best of luck. Let's see.
Okay, let's talk about what is coming to the web. Cool. So first of all, this is the 15-year anniversary of Chrome. So that's pretty cool. I feel like time has really flown. One of the cool things is that people reached out to me when this happened. They were doing kind of like an ad campaign on Twitter, and they were asking people like, what did you do when you were 15? Just like Chrome is today. And I fought back and found out that I was actually playing around with Netscape and Mosaic at this point. I probably just bought my first computer, and this is actually how I got started with the web. It was back in the day when we had a modem. I got Mosaic. It was really cool. And then this new browser, Netscape, came along, and I really got hooked. It was really funny. It was really early days. Since then, I joined this company called Nokia. We've been working on mobile technologies as well as working on browsers. So I helped develop a browser called the Nokia N9 browser. So this is the browser I worked on. It was a very nice browser engine. Actually, a lot of people that worked together with me, they joined Apple and worked on iOS Safari. So yeah, very modern browser. Unfortunately, this guy, Steve Neelup, he joined Nokia, and it all had to use Windows Phone, and no one needed me anymore because it already came with a browser. So yeah, I had to leave Nokia, and I moved on to this company called Intel. So I'm a principal engineer at Intel, and I work I work in our web platform engineering team. So I have worked on Chrome. I worked on WebKit as well. I worked on Chrome in many years. And today I'm mostly involved with standardizations of new and upcoming features. So I've also been on the technical architecture group in the WTC and in other standardizations. So I've worked on browsers for more than 15 years. I'm also one of the co-inventors of Progressive Web Apps, and this event is all about Progressive Web Apps. And today, most of my time is spent on looking on building these new upcoming APIs that we need to make the web compatible and competitive with native apps. So if you want to follow me on this thing that used to be called Twitter, now called X, you can do that. You can also follow me on GitHub. So the first thing that people always ask me is like, Intel, you're a semiconductor. Why do you care about software, and why do you care about web? Well, the fact is that every semiconductor, like a chip, is not worth much without any software running on it, and that means that if I make a new feature to a silicon, I need to enable that for developers. Otherwise, it's kind of useless. So at Intel, we work on many kinds of different software stacks. Work on Linux, on Chromium browsers, the bytecode lines with WebAssembly. We also do a lot of like hardware APIs. So we collaborate with the Wi-Fi standard, PCI Express, USB, you name it. And we really value everything that's open. We value choice. So whether you want to run Linux or Windows, Chrome OS, that's up to you. And we want to make sure that everything we do is trustworthy. So openness, choice, and trust. We're also quite sustainable. That's very important to me. So I'm very happy that's the fact. So why do we care? Well, first of all, developers, they need to develop things. They need to develop apps and experiences. And that costs time and money and requires skills. So if you're a company, you probably want to wonder, should I create a native app? But then maybe you need to develop an app for iOS, macOS, Windows, Chrome OS, and whatever else is out there. And you might not even be able to find the skills. Plus, of course, that costs. Then you require like different teams, requires a lot of money and investment to do that. So what we're actually seeing is that a lot of people are choosing web first. First of all, there's some great things about the web. As Danny mentioned, like you just type in the URL or click on a link and there you are. Don't need to install anything. So there's all kinds of great things. Like you can even like share a link to like a document I'm working on to a friend, and he'll get right there into that document and can start collaborating. All of these are great advantages of the web platform. But a lot of people, not just because of that, but they just want to reuse that web because they want to do that web app, but also want a native app, and they can reuse that for the Windows app and other apps. And that's what we're seeing. Sometimes people can do that all using web technologies. Other times they're choosing like a hybrid solution. If not all the APIs that they need are available. Something like there's something for mobile solutions for that, and Electron, for instance, is very popular on the desktop. So the Intel vision is that the web is an unquestionable key application platform. We want people to be able to create applications using the web. And it should be really performant, just like native apps. It should also have all the common capabilities that you need to build your experiences. At the same time, we want to strengthen the qualities of the web. We don't want to create a new thing, because that's been tried before, that people create maybe in zip, like a web app inside a zip file, but then suddenly it's detached from URLs. No, we really want to make sure that the web remain cross-platform. Everything's still based on the URL. It loads instantly. And of course, we need to meet and often exceed the user safety and privacy needs of users. Always do better. And we're actually doing quite well. Like web apps are installable today. You can even build very immersive web apps with great navigation, and they can be fast and smooth. Like Danny mentioned, we have the web app manifest, we have service workers, we have all kinds of new APIs like the navigation API and view transitions that makes it easy to create these experiences. But we're also like Intel really focused on performance. So there's WebAssembly, there's native support coming from machine learning, and we're building web into our hardware roadmap, which I think is super awesome. And there are all these new capabilities coming as part of the Project Fugu, such as the file system access API. But we really want the developers to be able to bet on the web. So create experiences with ease, let's magic. So always focus on the core. One example was the navigation API. We knew there was a lot of issues with the session history API, and people were building all these kind of routers around it. But why not then go ahead and just really improve the core of the web so that everyone can build these experiences with ease? But we also need APIs for everyone. We can't make every API on the web something that every website has to adopt or needs to kind of want to adopt. Sometimes if you say you're Lego and you want a web app to interact with your Lego thing using Bluetooth, well, that's not going to be possible unless you have a Bluetooth API. So we need to make sure that, but that Bluetooth API is not going to be used by many websites. It's only going to be by a certain subset. So we need to make sure that we have APIs that also for diverse experiences, not for experiences that everyone needs. And we need to be there for the next revolution that is happening. Like right now, it's all about AI and machine learning. So we need to make sure that you can do that on the web as well, without always relying on the cloud. Interoperability is also essential. You can't, like, it's all about being cross-platform. It's one of the advantages of the web. So you can imagine if you write an app and then you try it on Firefox and nothing works, you just get a blank page, or you click somewhere, it's not doing what it's supposed to. That's not great for developers. So developers need to be able to know which APIs are available everywhere, and we need to broaden that scope every year. And that's what we're doing with a project called the Interop project. So the major browsers, Firefox, Edge, Chrome, Safari, have gone together. They're asking developers every year, like, please tell us what APIs you really need to build your experiences. And then some of these are chosen, and every browser works together on making these widely available, making sure that they're really well covered by test so that the behavior is also the same. Not just that the API is implemented, but it should also work the exact same way. How is that technology going? It's going really well. It's really a winning strategy. We have 17.4 million JavaScript developers, last I checked. And at Intel, we know that more than 60, probably maybe more than 70 now, time spent on the PC is on the web, inside a web browser. And beyond that, people using apps like Electron, Spotify, that are actually built with Electron, and they're like also based on web technology. So actually, a lot of CPU cycles are spent using web technology. So that's really great. Actually, we have this. This is kind of a bit old now, but this is like an overview of how people are using the PCs on Windows. And as you see, like the number one app is Chrome. So that's a web browser. Then you got Edge. That's also a web browser. The third one is Firefox, also a web browser. Then they got Outlook. And Outlook is kind of like a PWA that's using the WebView 2 on Windows using Edge behind the scene. So it's also kind of web-based. Then you got other internet browsers. Then you got Excel and Word, which are also turning into web experiences. So it's really a lot of web. So we're doing really well. For upcoming APIs, or making sure that we have all these APIs available to developers, Intel went together with Microsoft and Google. Google came up with this Project Fugu, and we joined together. So now it's like Microsoft, Google, Intel, Samsung, Electron, and others all working together, making sure that we are bringing the right APIs to the web so the developers can build experiences that they want to build. And that has resulted in much better copy-paste, frictionless access to local files, safe access to external hardware such as over USB, Bluetooth, etc. Here are some examples. For instance, this is actually a very good example because one of my friends, Kenneth Augenbeck, he used to be the product manager on the PM on Visual Studio Code, and we had the discussion. So I was saying, like, why isn't VS Code, Visual Studio Code, a progressive web app? And he had like two reasons that I remember. One was it like, well, I need to access local files. I can't really do that in the browser, so I need to use Electron. The second was that, well, all these, like for highlighting code, say you're using Python, you want to highlight all the code. Well, to do that, they're relying on CPython because that's the implementation of Python. It knows all about the code. It can find the bugs and analyze the code. So that's really kind of like written in C and doesn't really run on the web. But today, Microsoft actually made it such that you can compile like something, like, as an example, CPython to WebAssembly plus something called WASI. That's an extension called the WebAssembly Standard Interfaces. That's a new name. It used to stand for System Interfaces. So additional APIs. They implemented those APIs, including file system APIs, inside of this web app. And now you can compile your CPython to WebAssembly and have that run inside of Visual Studio Code and have it all like a progressive web app. So that's really amazing. Another example, I think this is a prime example, because back in the days when I started working on browsers, we always had this idea, well, if there's one app that will never come to the web, it's going to be Photoshop. Photoshop is just way too demanding, never going to run to the web. And here we are today. You can actually run a version of Photoshop on the web inside your browser. And I think that's quite amazing. Sometimes these image files are really huge. They might be like 4, maybe 10 gigabytes, and it might not fit inside memory. So Adobe is using the Origin private file system that is created for file access, like super fast access to files. It's kind of hidden from your file system, as Stanley said. And that's super fast. So now this is used kind of like for swapping. And that allows you to have these really huge image files and have them work inside your browser. They also work together with us and Google on WebAssembly. So they're taking part of their original Photoshop, which is written in C++, and bringing that to the web, compiling it to the web. For that to actually work for them, we had to work on multi-threading support for WebAssembly and something called SIMD, which stands for Single Instruction Multiple Data. So chipsets today, you probably know there will be an instruction that says like multiply this number with this number, like 4 times 2, and they will write the result in another register. But actually a lot of chipsets, basically most, they have something called single instruction multiple data, where you can do the same on a vector instead. So instead of saying multiply 2 numbers, you multiply 2 vectors. Every component of that vector, maybe 4, it has 4 components in one instruction. And that will, of course, be much faster. So in this case, Adobe, on average, they got a 3 to 4 times speed up. That kind of makes sense, because if you go from a vector of 1 to 1 of 4, it kind of would give you a 4 times speed up if you have data enough. But in some cases, they actually saw, in one case, they saw 160 times speed up, which is like amazing. And all of this made it possible for Adobe to bring Photoshop to the web. With external devices, we have multiple companies doing that. One example is iRobot. They have this education tool called Root that allows like students to play around with programming and actually controlling an actual device. So I think like you can put like a pen inside of this device. It's like a Roomba, but it will maybe you will walk around you on some piece of paper and will actually be able to draw. And you can program all that inside your web browser and connect to it using Bluetooth. And I think that's really quite amazing. But what is really important about these like advanced APIs to talk to hardware is that we need to make it safe. Because like you're visiting many websites every day. First of all, I want to say that a lot of people have this idea that every native app are just safe by default. That's actually not the case. Yes, there might be a review process in an app store, but they're most likely not being done by actual people, because like there's so many new apps every day. So it's mostly going to be like on the compiled code, someone is trying to analyze it and finding some issues, but it's not all finding all of them. And also on native apps, normally when you ask for access to like one thing like USB, maybe you also get access to the file system. We can't do that on the web. So as one example with Bluetooth, when you go to a website, you have to click on something to show up a dialog. It's going to show you all the devices around you. These devices are not shared with the website at all. The website has no idea. Only the one you click on and connect to is then connected to. So all of these are designed with safety and privacy in mind, and we're constantly trying to innovate and refining our approaches. So the current focus at Intel, especially my team, because we're kind of a small team, is working on performance, achieving near native performance, optimizing our use of our silicon. And the second one is capabilities, which is mostly what I'm involved with, which is basically making sure that no silicon is left behind as everyone is moving to the web platform. So let's look at some of these new and upcoming APIs that we're working on. So there's WebAssembly. This is for bringing native code to the web. Fast, it runs on the CPU, fast CPU execution, support for multi-threaded and SIMD. WebGPU, modern GPU API, much faster than existing WebGL. Then the new API called the Web Neural Network API that we're bringing, that is going to allow you to do like inference on the client, and even using specific hardware coming to CPUs that is designed for neural networks. And a new API that I'm personally working on called Compute Pressure, that allows you to react to the pressure on certain devices, such as the CPU, maybe the temperature, and that's what we're working on. So first of all, I want to give you some examples of what we're doing at Intel to make sure that things run fast on our silicon. So here's one example. Basically, I believe that every common CPU out there that runs like Windows will support at least single structure multi-bit data of a vector size of 4. So that is what is universally supporting WebAssembly. But most of our hardware actually supports a vector length of the double of 8 numbers, like a vector size of 8. So what we're doing here is one example is that we started by identifying this at runtime, and then we're just like converting the instructions. And by doing that, in some cases, you see we got like more than 50% speed up. I think the minimum speed up we got was like 20%. So this is like one example of what we can do. Something else, most hardware today supports hardware-based decoders and now also encoders. So you can imagine if you're playing, if you were doing a video chat or like sharing my slides as I'm doing with you right now, that will have to be encoded on my PC and sent to the server. Otherwise, I've had to send all the raw data and do it on the server. It's going to be slow. So as we support this in hardware today, really should use that for getting better battery life and better performance, better, everything just being better. And as we have those hardware, like that wasn't possible before. So people could do like they could use what was already on the system. Maybe they could port FFmpeg using WebAssembly, but that was then only running on the CPU. So today we've been working together with Google on this new API called Web Codec that allows you, the developers, to actually use those hardware decoders and encoders in the software. So that is really great. Something else is that you probably heard about this. Most normal SoCs, they support different core types, like an efficiency core or performance core, or maybe even like different levels of these. So that's also what happens with Intel. Our platforms have E cores and P cores, P for performance, E for efficiency. And some of the tasks inside of Chrome are not really that important. So we can like schedule those on the E cores, like a background task. But if something is like display critical, it has to be on the P core because we want to show that fast to the user. So now we've been working on that in the Chrome project to make sure that everything, all the different threads, they kind of have like this thread type that's associated with what they're doing, and then we will be scheduling them correctly. And that has led like to 100 milliwatts power saving on a video call on Windows, as an example. Same thing with browsers today are multi-threaded, a lot of IPC inter-process communication going on. And we looked at this and really minimized it. This helps everyone, not just Intel. And just by doing this, we saved like 10% of the system on a chip power saving on a video playback on Windows. And I think like that's amazing. And that helps everyone across the board. So let's talk a bit about WebGPU. So WebGPU is something that you might not know that Intel has been highly involved with since the beginning. This kind of like shows you an overview of the timeline. And this has actually shipped this year, May the 2nd. WebGPU is in Chrome. So that is really great. So WebGPU is this new API. In the old days, we had for desktop apps, etc., mobile apps, we had OpenGL. And OpenGL, because it's the early days of GPU programming, it did a lot for the developers. For instance, it handled state. So that's kind of nice, but handling state that normally happens on the CPU. So there's a lot of like forth and back between the CPU and the GPU. And as time went on, and people really knew how to code for a GPU, especially like game engines are like, well, it kind of would be nice that I could handle state myself, because then I can maybe stay on the GPU longer and not be bound by the CPU. So people start creating these new APIs, like there's the Metal from Apple, there's Vulkan used on Android, and there's new version of DirectX on Windows that is like closer to the hardware, but requires developers to do more themselves. But that's what developers want today, and that allows people to do better, higher performing application experiences. And this is what WebGPU brings to the web. But it comes with its own shader language that works across different platforms as Apple, Google, etc. So it's really, really great. And here Intel has even been working on adding support to stuff like TensorFlow.js. But what is cool about WebGPU is that it's more than just graphics, because a GPU can also be used for compute. And this is now possible using WebGPU. So this is cool because now we can use machine learning. So Intel has been added that support to TensorFlow. So the WebGPU backend is owned by Intel and created in close collaboration with the Google team. So that's really, really great. And here's one example where you see that using WebGPU instead of WebGL or the CPU, whatever TensorFlow is using before, is much faster. There's one case I see it's a bit slower, but across the board, it is a great improvement. So here's one example of using WebGPU inside the browser to do stable diffusion. And let me just turn it on. So here you see that was done inside the browser without ever talking with the cloud. And I think that's really amazing, and it's always actually quite fast. Something that's interesting about machine learning is that there are many different ways to run machine learning. Of course, there's training and normally what you normally do at once, but on like your computer, you want to do inference. So I'm just want to check if I'm still on because something happened. Okay, can you still hear me? Yeah, it looks like people can still hear me. Okay, it's just my camera that went off.
I can hear you.
Perfect. Let me go back on. I got a message here. Yeah, so there's different versions of running this inference. Like you have the dedicated hardware. We call Microsoft and Intel and others call that an NPU for a neural processing unit. Google, they like to call it a tensor processing unit because they like talking about tensors. Then, of course, you have an integrated GPU, you have discrete GPU, and you have a CPU. In some cases, it's not like this one. It's not like the NPU is always better. Actually, normally the NPU is designed for saving power. So it's not the most efficient one that provides you the best performance, but it's going to be the one that requires the less energy to do something. So if you want to do something like background blurring, that's definitely what you want to use. If you really want the very best performance, you probably want to use a discrete GPU. But because all the preparation of the models and all the data normally happens on the CPU, that data will have to be copied to the discrete GPU. So that means there's a bit more like latency. So the best of the world, maybe an integrated GPU often shares memory with the CPU. So you see here that might be faster. But often if you just need to do like a small inference and like a one shot, often like the CPU might even be the better choice. So you see it really depends on the use case you're using, what kind of hardware makes the most sense. But machine learning can also happen kind of like in the background without you knowing. Like say, like Danny said, he's working with WebRTC, but WebRTC that handles your camera. So instead of you having to do like background blurring, it could just be like a knob saying like, please do background blurring for me. If you could do it in hardware, please do that. Otherwise, do it in software, or tell me whether you can do it in hardware. If not, don't do it. So we're bringing all of these things as well to the web browser. So a lot of these very common tasks as lightning correction, noise suppression, background blurring, it's just like an option you'll turn on as a developer. So at Intel, we've been working, especially together with Microsoft, on this new API. It's not in the browsers yet, but you should hear something next year. It's called the Web Neural Networking API. So that is bringing efficient machine learning to the web. And this is like a really proud moment for our team because this is the first time Intel officially is talking about this new product called Media Lake It was just launched, I think the 14th of December. And on the initial slides, we saw for the first time Web Neural Network API, like a web API, actually mentioned. So this was a really, really proud moment for our team. And as you also see on these very nice quotes, like Microsoft, Analytech, and other, like the industry is really excited about this new API. So you might be wondering, why do I need native machine learning on the web? Well, first of all, like we really don't want to disadvantage the web compared to with native. We really want people to be able to adopt web technology. And on the other hand, if you have something available, that often enables new compelling user interfaces, new user experiences that developers can use, something we'd never thought about. So let's look at the performance we are seeing with WebNN. So this is the implementation we have so far. So this hasn't shipped yet, but it's already looking great. So let's zoom in here. So this is one example where you see the one is just by using WebAssembly. So doing everything on the CPU by optimizing and using multi-threaded, using the SIMD instructions, we got a 3-time increase. So that's already great. But if you compare that with native, you see native is still like 3 times faster. But WebNN is very, very close to the speed of native. So that's really, really gonna be revolutionizing for developers, especially if you don't want to rely on the cloud. And actually, a lot of developers working with machine learning don't always want to rely on working cloud. First of all, there's the economy. You have to pay for everything running on the cloud, and it can really fast be very expensive. So if you're like if I'm doing my own app, I probably don't want to pay for that for fun. But if people are running it locally on their own machines, you don't need to pay anything. Then there's also all the thing about regulation. So we have all this regulation that maybe it has to be on a server in the European Union. Well, if it's on your own machine, there's no problem there either. So the lay of the land, and then also like performance-wise, like you get, of course, the best latency, the least latency by running it locally instead of having first to go to maybe to the US from Europe and then go back. So WebNN is just like WebGPU. It's a very low-level API, not something that average Joe developers should be using. They'll probably be using like a framework on top of it, like TensorFlow, JS, Onyx, whatever else is coming up there. Just like people not using WebGPU directly, they're probably going to rely on Babylon JS or Free.js. But it's going to provide like direct access to underlying hardware, CPU, GPU, NPU, to enable like close to native performance and reliability of results. So if you look at this overview, you can see like using WebAssembly, you can only use the CPU. WebGPU, it's only going to be GPU. But with WebNN, you're going to be able to choose what kind of hardware you want to use if it's available. As I said, the API is very low level, so not something that you probably are going to ever write. Instead, you're probably going to use a framework like TensorFlow, Onyx Web, or even like the media pipe, etc. But you might also using something even higher level, just like a library for noise suppression, background segmentation, etc. So let's take one example. So this is one of my colleagues, Belem Jiang. He's an engineering manager at Intel in Shanghai, and he's going to go through this example where he's going to show background blowing, first using WebAssembly, then with WebNN, and then he's going to do the same with web segmentation, and you're going to see the great speed up.
Kenneth, just a question, like does the video have any audio? Because we can't hear.
Sorry, there's audio. It's okay, apparently it doesn't work then. Oh, sorry. Let me speak then. So as you're seeing, I thought you heard the sound. He showed it in SIMD. That's what you see on the left. And you see by using WebNN instead, you see about 2.5, 2.7 time increase by using WebNN. So now he's using a bigger model, and he will show that with background segmentation. So let's go full screen. So now we're turning on background segmentation. So this is normally what you're using to find where the face is and replace the background. So now we're using it on WebAssembly SIMD, and you see the frames per second is like 50. It's like really slow. It's like 8 frames per second using WebAssembly. And you see the inference time is around 100, sometimes a bit more. By using WebNN, you see now the frame is around like 30, and the inference time is maybe 30, 40. So that's a more than around like 4-time increase on speed just by using WebNN. And this is still like with our current implementation, I believe that's even just using CPU. So that's quite amazing. Sorry about I thought you were hearing the sound. So the other API I've been working on is compute pressure. So this is part of telemetry. So basically knowing what is going on your system with your resources. We're currently looking at CPU, but this could scale to memory pressure, GPU pressure, and whatever else is on the system. So there's a lot of advances in using this. Like you can create like web experience that are informed by these system insights. So for instance, if the system is getting really slow because it's getting too hot, it can't keep up, the CPU is running at 100% utilization, maybe you want to like adjust your number of video feeds, maybe you want to lower the resolution, turn off some of the funny effects, etc. It's basically like what Netflix is doing and other streaming services is doing with bandwidth. They're like instead of like showing like a 1 frame per second, they lower the resolution to make sure that you have a smooth experience. It might not look as great, but you can still watch the movie. And this can scale into other kinds of insights, like I said, CPU pressure. But this is really, really difficult to expose to the web. First of all, everything that's global state can often be used for side channel attack. That was actually proven by me. So, and that meant that if you can do that, we'll have to invent like mitigations so that it's not possible. Otherwise, we'll never be able to ship such an API on the web. So it's really about the balance between like the level of data you're exposing and the usability. So we opted for some high-level states that solves the use cases of the people we have been talking to, at least like most of them. And in that way, avoids like fingerprinting or like privacy invasive fingerprinting. We have mitigation in place that avoids like the side channel attack, etc. So we have 4 states, basically nominal, not much going on with your system. Basically more like if you're idling or just doing very light tasks. Fair is like normal pressure, like when you're using the system, it's with great operating bounds, it's doing great. If you're going into the serious state, yeah, you can still do more, but you're getting close to the critical state. If you go into critical system, if you stay in that for too long, the system might start throttling, and you might end up with a bad user experience. So this is probably where you should try to do something if you can. Of course, like the pressure might not be done by you if someone is compiling in the background, as an example. This is one small like video showing you how this feature works. So I made this very nice web component where you can just observe. It'll show like this very cute emoji of how the pressure is doing. And then I have this Mandelbrot demo that is using workers. So as I add more background workers, it's increasing the performance, but it's also adding pressure to the system. So you see with 3 more, like now I'm going up to 6 workers, I actually reach critical pressure on my laptop. Of course, if I stop doing anything, it goes back to nominal pressure quite fast. And you can see if I keep on adding, like here 4, 3, it stays in serious pressure. 2, it's at fair pressure. So very simple API that allows you to observe pressure on different system properties, such as the CPU. So this API is getting very close to shipping. We actually believe that we might be able to ship in the early next year. So we passed all the security and privacy reviews. It's in an ordering trial right now, so you can play around with it. And we know it's being used by Slack, Zoom, Whereby, and others at this moment. They are participating in this ordering trial. So that's really, really great. We've also been working on optimizing power efficiency for media and streaming. You probably remember the COVID days when that happened in the early 2020s. Like, for instance, Goom saw like a 30-time increase in daily usage. So suddenly, from one day to the others, everyone was using all these online tools for meetings, or even like we're using StreamYard today for like an online conference. This became very, very popular, which of course meant that everyone designing hardware and APIs started looking at supporting these things as well. So for instance, at Intel, we've been really improving this API. We have like 20% longer battery life using Microsoft Teams and on the web and Google Meet. YouTube now is in line with native apps for power and performance, and Zoom got like a 75% video encode latency reduction by using like web codec. So here's one example of if you look at like Zoom, some of like we worked together with them and we tried to identify what kind of APIs they could use for different things and how you could improve the experience. So here's like one example where you see thing like WebRTC, you see web codec, and I forgot to add like compute pressure here as well. We also asked developers like what other kind of APIs can we add that makes this experience much better and makes it easier for people to create these experiences. And we got this as we got web codec was one of the things we've been working on, speech to text as well, noise suppression, line correction, background blurring out of the box, all of this. So we've been working on this. So here's some examples from my team. So this is running in Chrome. So experimental API that just allows you to do background blurring, basically as a 1-2 line code change. And as you can see, that works quite well. If that is supported by the hardware, if the hardware has like an NPU, that would be running on the NPU. That is the plan. And of course, like, I don't know if this is the final API as we're working with this, the team is working on it, but this would be like one example of how to do it. I think we ended up by having like 2 different states, like a small, like a little bit of background blurring and a heavy set of background blurring. But anyway, it's like a very simple API to turn this on. And the performance, of course, is much better. Like if you look at where you see the error here, this is if there's no background blurring, and you see it's using the power, it's like relative power, it's like at 1. Without proposal, it's just like a little bit more, I think like 10% more power. If you were to use something like Google's Media Pipe, that is what they're using for like Meet, you see that's like 2.5 times more power. And instead, if you use the BodyPix model using TensorFlow.js, that's also 2.3 times more power usage. So we've been also working on face detection. I think this is a very interesting thing, and my team has had a lot of fun working on that. Our first experiment was using OpenCV. We ported that to WebAssembly, running all on the CPU because WebAssembly is on the CPU. But the model was 8 megabytes, which is a bit big. So it takes a lot of time to download it, get it running. And on some devices, maybe mobile connections, it might not be the best. So Google, they came up with their own solution called the Media Pipe. It's kind of this. It's also using WebAssembly, but it's 2 megabytes. So it's smaller, but still quite sizable. But today we're working on just adding these features to WebRTC directly. So here's one example of my team where they have worked on face detection. And the great thing is that it actually works on more than one person. So if you see my other colleague popping up soon, and when he pops in the screen, and suddenly now it's tracking 2 people. API, very simple as well. We're trying to keep it as simple as possible. Here we're just saying like face detection mode bounding box. You get a bounding box. But in the future, we would like to extend this to maybe getting the contour. That would allow developers to add like funny hats, know where the noses, the eyes are, etc. Just as before, this proposal uses, I think this is like 20% more power than not using it, but that is less power than all the other solutions. So this is really great that you can add this to the web platform and use all the hardware that's available on the system. A couple of years ago, we also worked on adding support for pan tilt zoom. A lot of cameras actually support that in hardware. So you kind of had to do it manually. So if developers wanted to do this, not manually, maybe tracking someone, they would have to implement that themselves by analyzing what's on the screen and then adjusting these. But today we're just working on an API that will do all of that automatically, just to like track the user, and we'll do everything for you and use the hardware that's available. We're also working on, this is actually, they're starting the team. I think they sent out an intent to experiment or something similar to implement this to Chrome. So this is eye gaze correction. So if you looked at the camera once, the camera should have your eyes. And then most of the time, you're not looking into the camera because it's above your screen or maybe below your screen. So now instead, we can just like modify the image at runtime. So it looks as you're looking into the camera. And humans are all about like this, like connecting. So it feels much more natural and nice in a meeting that like everyone is looking into everyone's eyes. So also like that, just one line code change. Same thing with we added this a couple of years ago. Support for exposure type, brightness, color temperature, all of these very low level features of cameras. And now we just, why not just do it automatically? Use machine learning, whatever is on the system, to choose the right values and do it automatically. So that's really great. And those were the major APIs I wanted to talk to you about today. But I like saying one last thing and want to highlight the work of my colleagues. So here I want to show you something else we're working on, which I find super exciting. Unfortunately, there's no sound, so I have to go through it with you. So this is my co-worker, Alexis Menard, who's been working on supporting foldable display. So here you see one of these like new, this is an Asus ZenBook, and you can actually detach the keyboard. So he's showing this like demo he created where, of course, like it's a image viewer. You click on an image, it will show you that image centered on the screen. So that's great. But if you have like a full screen like this, you might not want it in the center. Also because a lot of these devices, they have this fold. That's not always so great, especially for touch. So you would like to know how the system is. So we've been working on a couple of APIs. One is I think it's called the Fold Posture API. So that kind of like says whether it's folded or not and how it's folded. And the other API is this window segments API that will tell you like this is where you have the fold, this is where you have the full screen, this is the top part, the bottom part, etc. And then you can like align things after that using CSS. So this is with the demo browser. You see now instead using this API, the image will show up in the top. So much better experience. But also, like if you have it, for instance, in the other direction, you could do something very different. Like you could show the image on one side, maybe even with additional metadata. Like here's a bit of text about the image. We also have another demo. This is a battleship game, you might know. And this is just a game that really says like, you have this big screen. Why don't you show the one I'm fighting against, playing against on the top, and my battleships at the bottom, maybe some game state in the middle. And with this new API, this is actually doable. So let's see. If you remove the API, you can create this whole different API. And that's really cool. We also have one last demo where we're showing like a newspaper and how you can also take advantage of these APIs. So this is like the fold news. So it's a news website. So you see in this way, we're just showing as a regular newspaper. But if you use this kind of book mode, you can kind of do it like more like a traditional newspaper experience. And if you do like a flat mode, this is basically where you use as an external monitor. It will just show like any regular API. And you can imagine like you can use this API, for instance, for a meeting. This might be nice where you're seeing your friends on one side and the other side, maybe you're working on your meeting notes. So very cool new API. So with that said, at Intel, we're working on empowering the web and future experiences. So let's see if I can go back to the meeting so I can hear if there are any questions. Perfect. I'm sorry about my camera, it stopped working.
It's not working. Okay.
No.
You want to try to get out or get in again? Usually turn it off or turn it on again. It works, but maybe later.
Yeah. Let's just talk here. So fine.
Okay, so we have one question that I loved by Jefferson. That I think it was about the stress code. Like I want to know how stressed I am during the day. So I think you showed many projects. So first of all, thank you so much. It was an amazing presentation, great showcase. Good thing is that like tomorrow I'll watch this episode again because I have to add the timestamps, so I have time to rewatch it again in a quiet mode. And so do you have, is there any repository or any project which is open source for what you show or not?
Yes, that should be the case. So like as you said, like I talked about many different APIs. So with the web GPU, for instance, there's a lot of articles, especially Francois Beaufort from Google have been creating a lot of articles. I believe it's on web.dev. It might be on the Chromium blog as well. So definitely we can try to find these. I think web.dev would be the place. There's basically like showing all the, because like web GPU is not a fixed API yet. There are a lot of other extension APIs we can implement to make it even better. And people are working on adding those all the time. So there's kind of like these updates coming out once in a while. With all these specific APIs, as the background blurring or the compute pressure API, these are standards. So you can just search for them like W3C, compute pressure. You should be able to find the repository where we're doing the whole like the specification. And often these specifications will have some demos. There might even in the repository be like links to a demo. I know for compute pressure there is one demo. You should be able to find everything there. And if not, like file an issue on the repository and ask people. Is the way, because like there should be like a readme.md that will talk about the API, and we can definitely add links there.
Cool. Nice. Thank you. I think we have one last question, then I'll get Danny back, and then we wrap up this daily.dev 2023. How long does it take for an API to be fully implemented?
Well, that
$1 million question.
Yeah, that's a $1 million question. Like Danny mentioned some of the APIs I've actually been personally working on. So like there's the shortcut API. I don't know when we did that. I think I initially did that when they added support for these long press menus on Android, and then like it got nowhere, and then eventually Microsoft they showed interest to bringing this to Windows, and then they took over the spec, and I think maybe that took like, I don't know, at least like 3 years, maybe 5 years, so a long time. The improved PWA install experiences with the screenshots, that's also something I spec'd long ago, and there was no interest. So this is when Microsoft started getting interest in progressive web apps. So this is like really the early days of progressive web apps, and we were first seeing that like a year. I think like that launched like a year ago. So some things really take a long time. I worked on web and NFC that took around, I think, 4 years, but it really depends on the API. Sometimes there's something that sometimes it's a simple API, right? It's a CSS feature. Maybe there's a lot of interest from every browser, and then maybe it can launch in just a year or two. We've seen that. We've seen that with like view transitions. That the work on that didn't start like, I think like a year, maybe a year and a half ago, and it's already launching Chrome. It's still not widely available, but I guess it will be available widely in a year or so. So some APIs, they don't take a long time. Other APIs take a really long time. So there's there's a lot of different complexity in different APIs. Like something like web Bluetooth, for instance, it's a very complex API. Bluetooth is very complex, and it's really difficult to create an API that is simple to use, that developers can use easily, that's safe, that solve all these privacy issues, but they're managed. like I really love the Web Bluetooth API. For instance, I've worked with teams that worked on Bluetooth and worked on the standard and worked on the BlueC stack on Linux. And at that point, I had to work on some USB device using this like BlueC API. And oh my God, like you had to be a Bluetooth expert to know it. Like you really need to know all the small details. And I basically like gave up. It was very difficult. But with the Web Bluetooth API, it was just so simple that everyone could basically like connect to a Bluetooth device. So some things just take a long time because it has to be done right. But when it's out there, and I think that's the amazing thing, when something is in a browser, especially when it's widely available, like it's so powerful because everyone is going to start using it and to create all these amazing experiences, and has to stay there for so many years. I think that's also the challenge we have. On native, you normally just create an API. If it's not great, well, then you deprecate it. So you say like, oh, well, if you want this new to create an Android API for this new device, well, then you're gonna like not use these APIs anymore. It's gonna be deprecated for a while, then gonna be removed. And we can't really do that on the web. So we really need to get it right. So that's why, and we need to get everyone in agreement. So even if Apple said, I don't want to implement, like I worked on Wakelog API, and there was no interest on Apple. They thought it was not a great idea. And we argued that Wakelog is actually great because people kind of don't always want the screen to turn off. Like if you're doing a recipe app, you probably want to read the recipe and you have dirty fingers. So every time you need to clean your hands to turn it on again, not a great experience. And we saw that developers were finding workarounds, like playing a 1 by 1 pixel video in the background, draining the battery of a phone, which is also not great, but people had to do that because then it wouldn't turn off the screen. So by doing this API, we worked many years to make it really great, and we thought about like, okay, so Apple, they don't want this API, but we still want them to be able to implement in the future. So I need to understand what they like about it, what they don't like about it, and design it in a way that they can implement it at some point. And today we're here and they have implemented it. So now it's widely available. So it's really a different journey, and it really depends on the API. But it's not from one day to the other. Let's put it that way.
Nice, thank you. And of course, you're saying like you were saying about doing a recipe with dirty fingers, and as an Italian, I can understand this pretty well, I will say. Yeah. Now, so let me invite back Danny. So, Danny, thank you so much for waiting, and we are at the end of this, let's say, series, if you want to call it like the third series of the Monthly Dev. This, as I said, has been the 36th episode. Maybe we can stick around for 5 more minutes or 3 more minutes, depending on the question. Maybe we already have one, and then we can wrap it up. So nice. Thank you so much, Kenneth. Yeah. If you want to try to turn on the camera, you can, or you can just have you.
I can turn on another camera, but this is gonna be worse. My external camera stopped working. My internal camera might work. But it's not the same quality.
Oh,
it's okay. You're back. You are still handsome, Kenneth. So no worries. So I think there is one. Lazy Alpaca asked, where can we follow such new developments? What do you mean, Alpaca? Like styles? Probably they're asking for some links. So we share the link of Danny. But yes, you also mentioned so many projects, Kenneth. Thank you.
Yeah, I think like the best way to follow is like web.dev is a great resource. The MDN, like the Mozilla Developers Network, was not just done by Mozilla, by the way. It's also great. They also come up with new articles of new APIs all the time. If you really want to follow what's happening as it's happening, Twitter X is probably the best place, but you will have to find out who to follow, which is kind of a challenge. But like you start by going in there, you start by adding like the browsers, like the Chromium dev. Then you see like who they're retweeting, and you start following them, and you see who they're retweeting and what is great, and you follow them. That's a good way. Like you could find me and Danny, and you can see who I'm following. That's working on the web, and maybe you want to follow them. People working, they'll probably say like, I work on the Edge browser, I work on Chrome. That's the way that you're gonna like know what is happening as it's happening. If you don't have the time for that, web.dev is probably one of the good resources. There's also a lot of developers doing like YouTube shows. So that's also another option. Or they have like a mailing list like Danny has. But it's really, there's no one place to go to. Web.dev is the Google thing they're doing with Chrome. They're also having one for specific Chrome. I think developers at google.com/Chrome. That's just for Chromium APIs. But yeah, it's not that easy, but you will find it.
Yes, so Kenneth, I'm absolutely disappointed. No, I'm joking, because at Daily Dev, one of the things that we do is like to let the developers stay up to date. They can follow along, they can take some tags, and they can follow me. So probably Daily Dev can also be a good and free way recommended. You can absolutely check it out. Thank you so much for the hook. Suppose I'll just share the screen so you can check it out. And this is Daily Dev. Daily Dev is a platform for developers by developers. As you can say, as I said, like you can follow any topics, also PWA and anything you want. And basically basically we curate your feed. You can select something, and you can block some sources. You can really customize what you want to follow. We also have this cool new feature which is called squads, and you can have, for example, we have one called web dev, of course, web development, always the same word. I think it's not the same thing. And it's, but for example, here you can also follow along. So there are many different ways. But yes, of course, I'm biased, but I really like, for example, Daily Dev, the platform. This is also why I joined, of course. And yes, so thank you so much, Ken. Thank you so much, Danny. I see some people here in the chat. If you want to say bye, if you want to say have a great 2023, Danny, would you like to say something before we wrap up this?
I would just like to thank you also for having me, and thanks everybody for joining. I just hope everybody got a good overview of what is possible with the web today, because that's something that we're all passionate about. And just let's hope that 2024 will be the best year ever for the web.
Yes, Danny, I think that it's hard to go wrong, let's say, if you go into web development. There are other types of development, but it's probably the one that I like the most. There are other stuff, of course, the DevOps of the DevOps world. It's probably my favorite, but still like the web development. And I think I also learned a lot. So thank you so much for your great talks. They were
Thank
great.
You.
As I said, I'm lucky because since I'll watch the video tomorrow when I'm not in host mode, and I can be delighted by all the details and the stuff and the presentation. So, yeah.
Thank you so
much. Nice. Thank you so much. I would like to end with this comment by Michel. Daily Dev is why 2024 would be 2024. Love it. Thank you so much. You made my day. And nice. Perfect. So thank you again. It was great. A great topic. Great, super knowledgeable speakers. Loved it. Nice. Perfect.
Thank you.
Thanks for listening.
Thank you. See you in
bye-bye.
Yeah, bye-bye. Thank
you
so much.
Happy holidays. Bye-bye.
Yeah,
Happy holidays.
Absolutely.
Bye.
Okay, nice. Bye-bye. See you in 2024. Bye-bye.
See ya.